This is an introduction to random numbers in C++. First of all, where are random numbers used on the computer? Well, they are used extensively in games. When you play a game such as solitaire, every time you play, you don't want the cards to come up in the same way. Random numbers can also be used in statistical programs when you need to take a random sample. And also, one of the most important places that we'll use random numbers is in security. So in security, like for example, when you go to a secure website, which is most websites these days, then your information is encrypted, and a randomness is used within that encryption. Okay, and also the keys, the public key is selected randomly. Okay, so now to do random numbers in C++, it's possible, depending on your compiler, you may need to include the standard library.h. Okay, I don't need to, so I'm just taking it out there. So just FYI, if it doesn't know what the random function is, then try including that. So the random function, cout rnd, is the random function. Okay, and so it doesn't take any parameters. Other programming languages, you'll see it has parameters, a little more user-friendly. So this is what comes up. So when we do that, it prints a random integer, 41. Okay, but now let's run it again. 41. Okay, let's run it again. 41. Oh, what are you telling me, that there are no random numbers? Yeah, there are no random numbers. Okay, so actually, we don't have, built into the language is not true random numbers, it's simulated random numbers. And by that meaning that, well, the reason for that is because computers, the CPUs in computers are deterministic. They follow instructions. They can't just do something random. So we kind of have to simulate random numbers. And so we'll have the random function is a function that gives you a simulated random number, but as you can see, it gives you the same number every time you run the program, which is not good. So, for example, let's just do 3 random numbers. Let's compile and run it. So I get 41, the same 41, then 18,000, 6,300. But if we run it again, I get the same thing, 41, 18,000, 6,300. So these aren't, but the thing is, every time you do the random function, it will give you a random integer. And if you do it more and more times, they appear fairly random. But again, when you run the program again, you get the same numbers. Okay, so first of all, let's talk about turning these big random integers into something more usable. Let's say a random number from 1 to 10. Well, to do that, what we can do is, since this is a random integer, we can just mod it by 10. So remember that the mod gives you the remainder in a division. So if you divide any number by 10, then the remainder is going to be a number between 0 and 9. So therefore, if you want, so this would give you a random number from 0 to 9, but if you want a random number from 1 to 10, well, just add 1 to it. Okay, so I'm going to copy and paste that to there and to there. And so now we're going to have 3 random numbers, or simulated random numbers, from 1 to 10. We get 285. Of course, that didn't fix the problem with it giving the same random numbers every time you run it, 285. Okay, so now one thing you can do so that you don't get the same random numbers every time you run the program is you can seed the random number generator. Seed RNG. And we have a function called srand, seed the random number generator, and you give it a parameter. Okay, so if you give it a number, that will change the random function and you'll get different random numbers, but you'll still get the same numbers every time you run the program. So, for example, now I get 975, but run it again, I get 975. So I'm getting 3 different numbers, but every time you run the program. So traditionally, what used to be done is to seed the random number generator with the time, because computers, ever since the 1980s, have had a real-time clock built onto the motherboard. In fact, there's a little battery on the motherboard that powers the clock, even if it doesn't have power. So if we include time.h, that allows us to pull the time off the motherboard. And so we'll put the time function in, and you need to send it the parameter of null in all uppercase. Okay, and what this is actually called epoch time. And that gives us the number of seconds that have elapsed since January 1st, 1970. Okay, and so this number is changing every second. And so now every time I run the program, assuming I run the program at a different time, I'll get different numbers. Okay, 391. Let's run it again. 628. 989. Okay, so now we are getting different random numbers. However, that assumes you run the program at a different time. And one thing I like to demonstrate in my class is this is the old Windows XP solitaire program created with Visual C++ and uses the same random number generator and seeding that we did right here. And what we demonstrate in the class is that if everyone opens this solitaire program on their computers at the same time, and assuming our clocks are all synchronized, then we all get the same cards. So it's kind of an interesting demonstration to show how, a lot of programs are not, the random numbers aren't very good. Okay, so so now what you can do is there are other ways to seed this random number generator so you don't have that problem. For example, since we're hooked up to the internet, we can seed the random number generator from some source on the internet. We can pull down. Okay, and so, but now, even with that seed, we still have the issue with simulated random numbers. And so now that brings up another topic, is there's such a thing called a hardware random number generator. Okay, and this one's a card, but you could pull random numbers or a random seed from the internet that comes from a true random number generator. And these true random number generators use some aspect of quantum mechanics, and such as the photoelectric effect. And quantum mechanics, if you study chemistry, built into quantum mechanics is a true randomness according to today's science. So using this, as far as we know today, you can get true random numbers. And if you're running a security server, then you probably want true random numbers on there. Okay, so now so here we just outputted 3 different random numbers. Let's talk about how we could use random numbers to print out a random statement in a program. Okay, so for example, let's just make int r is equal to a random number %3. That will give us a random number from 0 to 2. I'll just add 1 to it, so it'll be a random number from 1 to 3. And so now we can do if statements. We can say if r is equal to 1, then cout you're awesome. And then we can say if r is equal to 2, cout you're great. If r is equal to 3, then cout you're just okay. Okay, so now this should print out a random statement from a list of of 3. And so outputs great, run it again. Outputs you're just okay. Let's run it again. You're awesome. Okay, so I got all 3 without any repeats. Okay, so this is a quick introduction to random numbers in C++.